The magic happened. You are now in the special place.
Welcome.
Welcome. Hey, I guess we should have a talk.
Yeah.
I'm up here being Mats Torgersen. I am the current lead designer of C#. The previous one is around somewhere in the conference, so I'm a little careful about what I say today, but if you find him, tell him thanks. He started the whole thing. And here we have.
And I'm Dustin Campbell, and I'm an architect in .NET Tooling, and I'm also a member of the C# language design team where I get to work with my fine friend. All right, and yeah, and the previous guy, there is no previous guy, it's fine for me.
So here is the second of our 4 slides.
Yes.
And the last one is the thank you slide. This is about if you have any questions about C#, which I know a few people do, but if you do, there are like QR codes there. If you scan them, you can ask questions in Pubble. And we have a table of very accomplished question answerers over there. We have Cyrus Najmabadi and Fred Silverberg, who are also on the C# language design team. And we have the inimitable Jeff Fritz.
Inimitable.
Immutable and inimitable. And
yes.
Whatever I just pronounced.
Yes.
Now, there's a little bit of a problem. The idea is they throw questions to us up here as well on the screen down here, from time to time. Those questions are currently this big on the screen, so we may not be able to take any questions on stage if that continues, but they're really capable. They will answer along the way.
And also, we will be, after the talk, we'll be in the .NET Expert Meetup room. Both of us and Cyrus and Fred will all travel down there, and we can answer questions there as well. So.
Yeah, and if you miss us there as well, you can just send us an email.
Yeah, we full-heartedly put our emails up there.
Yep, and also, we're going to switch over to my screen now, and we'll show you a few other places that you can engage. And then once the PM up here is done showing you web pages, the engineer will take over and get you into actual Visual Studio, and we'll just do things.
As it should be at Build.
As it should be, yes. We will, in fact, build things. You should go check out the C# docs. They are really great. They actually have a What's New in C# that has already started populating C# 12. It follows along with what's out in preview, so you won't see most of the features that we're showing today because they're not out yet. But it's going to populate as they come, and until we release in November-ish timeframe when .NET always releases. You should also check out, if you want, the C# language strategy. That is sort of our long-term statement of how we think about designing C#. Like, what are our values? How do we make choices about C# in the very, very abstract? There's one for F# and VB as well, if you want to compare and contrast. And that can be a good read. We also actually have a standard, C# standard. It's currently 4 versions behind, but it's catching up. And you can go and read the C# spec down here somewhere, specifications.
For some light reading. Yeah.
And that's actually open source, and you can go contribute to it.
I keep one of those in the bathroom.
Yeah. Sounds always good.
Light reading.
If you want to check in on what we're currently working on, the best place to kind of get a quick overview.
I believe it's overview, yes.
Overview.
Yeah.
I'm not an English speaker, whatever. Is over in Roslyn, which is the open source project that implements C# and VB, essentially compilers and core tooling support. Always has a feature status thing. You can just go and the language features are here. C# Next is everything we're currently working on. That doesn't mean it'll ship in the current version or, in fact, ever. We might drop some of it. But you can see the ongoing work there. And all these link over to C# Lang, which is the repo for C# design. And this is where we spent most of our time. This is where all the artifacts related to designing C# live. Like everything from the C# language design meetings, all the meeting notes are here. Fred over here actually writes them.
So yeah, if you have trouble with them, he's right there.
Yeah. If you have any questions about that, you should not let him leave this room.
Yes.
Proposals for new features.
Many of those are by Cyrus, who's also sitting right over there. So again, any problems?
Cyrus is very active in there as well. And discussions about potential new features, issues are kind of more structured feature proposals that we're evaluating. So it's a good, very active place. And that's kind of all what I wanted to show you.
Yeah.
Now let's go over to
Let's go to code.
the place we call home.
Yes, the place we call home, which, because this is build and it's our talk, we're going to have, the same kind of demo we always have because it fits on screen, right? So person, student, that sort of thing, right? It's instructive. And it fits on screen. So what we've got here is we've got this student in a record class, and we're passing in a name and ID and some grades. And this is a very simple kind of POCO kind of situation.
And this currently works in C# 11, right?
Yes, this is C# 11. Yeah. By the way, we haven't been on this stage, in person since 2019. So the last time, if any of you came to that build, the last thing you heard, if you didn't watch us online, was C# 8. So we've had good 4 versions of the language since then. So if you need to catch up, you should use the links that Mads just shared, because a lot's happened since the last time we were standing here. So this is C# 11. And with this version of the language, we've got a lot of cool little features that I think, there's some nice bite-sized ones that are just really helpful. And we've kind of had, in the last several versions of the language, we've had features that are all about removing boilerplate and just taking some nice kind of conveniences, maybe fixing some of our, just kind of features that maybe don't feel quite so fleshed out or so easy to use anymore.
That's what we got, one of them that we can start with here, which
we do.
is actually a thing that wasn't quite fleshed out since C# 1.
Yep.
So we're kind of getting around to fixing that up. It's a tiny little one, but it's a good palette cleanser to get started.
And it's right here. Yeah. How many people have written I don't need a show of hands, I'm sorry. I can't even see you, it's fine. But like namespace alias or using alias where, type alias where you want to use like an int or a decimal in this case, but you got to spell it all out. We require you to know that full type name and type it right there. It would be great if you could just type that keyword, because it turns out that C# has another way of saying that, right?
Yeah, you couldn't use a keyword type there ever before.
You're welcome. You're welcome.
Right? And that's so this is it feels like just a tiny little syntactic fix.
Yeah.
But it's a little bigger because there are actually a bunch of things you couldn't express until we generalized the thing on the right-hand side of the equals to be any type.
Yeah, let me give you another example. You've always been able to put tuples over here.
Oh.
Yeah, you've always been able to do that. That's pretty cool, right? How many people even know that it's backed by value tuple, right? But you could always put tuples there, but it's so cumbersome. And so now that we can put other syntactic constructs other than just names over there, we can easily do that like so. Huh?
Yeah.
But even better,
but wait.
There's one thing you couldn't do, which is you couldn't put names on them before because that gets baked into, suspiciously weird little attributes around the tuples.
Yeah.
And so now you can, right?
Yeah.
And now this actually becomes using type aliases become even more useful.
I like how we can take these old flaws in the language and just fix them trivially and go to a conference and tell you about it and they'd be like, look at this awesome stuff.
People love.
We fixed a thing.
They love bug fixes.
Yeah. There's one more thing that you couldn't do then. That was pointers.
Yeah, we do pointers. And so this program obviously has got Mads here, and he's got some questionable grades. I assume this is where you turn.
Not to bring it up.
This is where you hit drinking age in college or something. But so perhaps you would want to, instead of stating your own grade, maybe you'd want to make this a pointer so that you could point to somebody else's grade. Right? Well, of course it's arid. It's arid. No, it doesn't work. And the reason it doesn't work is because, why? Because pointers and fixed size buffers can only exist in unsafe contexts in the language, right? You have to use that unsafe keyword. And so we add that for using directives so that you can do exactly that.
Yeah.
Okay? So just some nice little fixes, tweaks that really improve things. So yeah, our palette cleanser.
Yeah. And let's not talk about my grades again, okay?
No, that's fine. We won't bring that up again. It's definitely not in the demo.
Okay, for something a little bigger though.
Yeah.
We have a record class up here. I don't know how many of you ever got to really look at records. Some of you probably, some of you not. There's something that records have that would really be great for all classes and structures to have, and that's what we call primary constructors. That's this that the class name is followed by constructor parameters directly, and they're just in scope.
Yeah.
But for records, so records have had this for a couple of years. And when we added them there, records are very special. They're meant for representing data. And so it was natural for records that these parameters would automatically show up as properties, public properties,
Right.
on the thing.
In fact, if I dot into MADS here, you can see all those properties, the ID, the name,
Yeah.
GPA, grades, they're all there, right?
And so the thing is, primary constructors are actually kind of cool in general, but it's not so cool for everything to show up as a public property when you want to use more classic object-oriented encapsulation and so on. You want more control about whether and how you essentially surface these things that come in.
Mm-hmm.
And so,
So we can do that. We can just, delete the record keyword.
yes, so now it's an ordinary class. And now you have primary constructors in all classes and structs.
Right. Now these are, of course, we're getting warnings that these aren't read anywhere, which is interesting. I should also rename these because these are no longer declaring members. They're now parameters.
Yeah, if you actually go and look at MADS dot,
Yeah.
you can see
Whoops.
that they're actually we no longer auto-generate. For
Yeah.
these, we don't auto-generate members for you because we don't know what you're going to do with those constructor parameters.
Yeah.
But it's still useful to have them, and to show that, we can go and actually surface a couple of them.
Mm-hmm. Yeah, so because they're unread, we could read them. That would be fine. Maybe we want to actually expose, a property for name and with a public getter and setter, and we could initialize that with a value
Yeah.
of name and just use that parameter coming in. This is the primary constructor, so these are parameters now, and we can use them throughout the instance members in our class. Right?
Yeah.
Or we could take ID and we could say, well, that one I don't want to even declare really any, a getter or anything like that. I would just want to make that a getter only, and so we can return the ID just like that. Yeah.
Yeah, there's an interesting thing going on here where if you notice the name parameter is only ever used to initialize something else.
Mm-hmm.
Like it comes in when the constructor is called, that primary constructor is called, and then it's being used for initialization, and then we don't use it again. Okay, so that's just like a normal constructor parameter. But the ID parameter, and actually also the grades parameter further down, is being used in property bodies, so it's being used after the constructor is done running. And so we do with these parameters essentially what we do with all other parameters when they are used after the thing they were parameters to, so to speak, right? We capture them. So if you think about Lambda expressions that use parameters and local variables from the enclosing method, that Lambda might survive the method. And we just make sure in the compiler that we capture those parameters or locals into something, into an object that will keep them alive after the enclosing thing is run.
So you just said that we just turn classes into a giant Lambda expression. That won't make anybody uncomfortable or...
Oh, did I explain this the wrong way?
No. But truly, yes, the fact that we capture these things and so that they are in scope in these other places,
Yeah.
which is super useful. Yeah.
So the way that they're captured here is probably, as an implementation detail, that we generate some extra fields on the class to keep them in, just like what you would have done to keep them around.
Yeah.
But we don't show, that's not part of the sort of language semantics. They really are just parameters. You can't say this dot lowercase ID.
Now, we do also have in this class, it's a kind of interesting part of this is that we have another constructor, right? And it calls our primary constructor. And we call it the primary constructor, or as I call it, constructor prime. But yeah, we have that. We have to always call that. So constructor chaining, when we chain constructors normally, we've always been able to call this and call another constructor or base, and But no, now when you chain, you must always get to the primary constructor, right?
Yeah.
However the chains go, if you call another constructor, it must ultimately call the primary constructor.
So it's this calls all the way until
Yep.
it reaches the primary constructor. But then who calls base? Well, the
Yep.
primary constructor has to call base.
And it does that by when it declares its base type, right?
Yeah.
So I can come in here and say, well, student is a person, right? And I can pass in the name right there.
So that's where you pass arguments to the base.
Yeah, so just as you expect it to work.
Yeah. So I
Now,
think that
we do have, I should point out before you go on,
Okay.
they have managed to adjust the font size so questions can be viewed if you so desire. And there is one question there.
That is-
However, they do not seem to scroll, so that we can only answer the first question.
well, let's answer the first question.
Okay.
Is grade type checked as grade or as decimal?
Yeah, so talking about this guy up here is grade,
Yeah.
type as grade or decimal.
For using aliases, they are really very thin aliases. They are just another name the compiler uses for the same type. So they're checked exactly as decimal. They have no, this interestingly foreshadows something we're going to talk about later, but we'll get there later. But no, they are just another name you can use that for the same type.
Just like using type aliases always worked, right?
Yeah.
It's just that we can be a little bit more flexible with what we can put on the right side.
Yeah.
That's the feature, regardless of our joking around it. So
Yeah.
all right.
Okay, let's see if it can scroll.
No, it does scroll. That's the previous thing.
Oh,
Yeah,
okay.
that was
got
a test feeder question.
Okay.
So we're in good shape here.
Yes.
Okay.
Okay. Excellent. Yeah, so that's pretty much it for primary constructors, I think.
Yeah.
It's kind of like on the one hand, it's like, the reason why it took us a while to get primary constructors for all classes and structs is that we kind of had to make a feature that was less than the one we have for records, right? It gives you the constructor parameters and scope and everything, but it does not surface automatically surface them as properties with the same name. And strangely, that was actually harder to design. Like
It was. I mean,
all the scope rules and how things look up and so on, that was actually more gnarly.
you know, to be fair though, we had this once before, right? We had primary constructors back when we were working on C#6. Was this different from what we did in that?
Honestly,
I don't think it was.
might not have been.
It may be exactly the same. Which, by the way, we didn't do primary constructors in C#6 because we had a choice. And it was do primary constructors, which would have added a lot of value, and we're so sorry, or do C# interpolated strings. And everybody said thank you. So
We're out of time.
I think we're in good shape.
We didn't do this one.
Yeah.
There you go, primary constructors.
Yeah. So looking at this code, you know, maybe we got this primary constructor, and what we're taking here, we're taking a name, we're taking an ID, and an array of grades. And, you know, maybe we want to change that collection type to something else, right?
Yeah.
Maybe we're like, I don't know, maybe it's Tuesday and we're list happy, or we expect them to be able to add things to this, right?
It makes sense that you could extend the list of grades and
Yeah.
make it longer. Let's use
I suppose so.
Yeah.
Okay. Now, the problem with that, of course, is that all of the call sites, everything has to be updated because it was all taking arrays before. And so we have to come up here and change this to be a new list, right, that takes your stellar grades. Now, we can do that super easy, right, in recent versions of C#. If you haven't been keeping up, there is target typed new, which allows us, if we can figure out what type this is supposed to be from its context, and here we're calling the constructor and we know it needs to take a list of grades, you can just leave off the type name. It's fine. So I can just change those to parentheses. That's fine. And then down,
bad.
it's not super bad. That's not super bad.
But let's just call list.empty instead, right?
Yeah, we can call list.empty here.
Oh no, list doesn't have. Actually, there isn't
list
even a
of
list.
decimal or
List of
grade.
decimal,
Yeah, maybe
sorry. Yeah.
empty. Yeah, this is
Should have practiced it.
this is terrible. This doesn't work. So I guess
This doesn't have an empty.
it doesn't seem to have an empty. That's terrible. So we
Sure, you
should
create an empty list.
we can do that.
New up an empty one.
We can just go up a new list. That feels shameful, but
Yeah, so this is kind of bad, right? We're like, new collection type, we have to kind of figure this all out again. Well, how do you make these ones?
yeah, and they're very different, right? Array's got this special empty method that's, you know, nice to call, so you don't have to, you know, constantly be allocating new empty arrays in your code, and you know, but you got to go through each one and figure out what the right syntax is.
Yeah, and if we were creating another kind of thing, say mutable array or something like that, then the object initializer approach that we have on the screen now would also not work because they're not mutable, and object initializers work by adding things.
Right.
So actually creating an immutable array, for instance, today.
Oh yeah,
is
doing
really
an immutable
bad.
would be terrible.
Yeah.
Right. So
Not even going to show it. That's how bad it is.
yeah. So if we had a different syntax, something that was kind of neutral, that we could pass in all places, right? That might look something like this. Some other kind of literal. We call that a collection literal, where it is essentially target typed to the thing we're passing in and figures out and knows how to construct the thing that you're trying to pass it to. Okay? And so down here, though, of course, we don't want to new up a list. There's probably a better collection literal syntax for that, right?
Yeah, I mean,
I guess it's the same kind of thing, just like
same one, just empty. Right?
just like that.
And so there you go. That's collection literals. Okay, and they just.
Now,
just to make sure, they work for other collections too, right?
They do work for other collections.
Not list literals,
No.
but if we went back to array, for instance,
Or you mentioned it earlier, we can also do something like this.
You're
right?
right. Immutable
They could
array.
work with a mutable array. Or we could go all the way back to array. And so,
It just
and it just works fine, right? Now the syntax itself is kind of interesting in that where did that come from? Well, if you've been keeping up with C# and pattern matching, and every release it feels like, hey, here's your new pattern for the release, right? And recently it was list patterns. And so down here we have list patterns, and so you see this, that empty literal that's used up there is also in the list pattern to match an empty list, right? And so there's a symmetry here that as we're using more list patterns and we're seeing list patterns in code, on the other side, things can be constructed with collection literals, right?
It's actually kind of funny with pattern matching. Oh, by the way, I'm just realizing we forgot to put a new kind of pattern into C# 12. So I'm really sorry about that. There will be no new kind of pattern in C#.
Well, that changed the talk.
But yeah, okay, we're not done yet, I guess. But this whole pattern matching, as we've been rolling it out, we've tried to keep as much of a syntactic kind of correspondence between the way objects are created syntactically and the way that they're consumed in a pattern. And this is the same thing, except we're doing it the other way around. We started with the pattern, and now we're mapping that back to how do you actually, what is a good syntax for constructing a collection?
Right.
So that you can kind of keep okay, here I'm building it with square brackets, and here I'm pulling it apart again with square brackets and getting at the inner side.
You just reminded me of something. We haven't actually built this program. We should see what this does, right, as well. Because we have your grades, and as stellar as they are, we should print out what that's going to print.
I told you not to bring it up.
I don't know. It's an easy joke, so I'm going to do
yeah.
that. I'm good at those. That's what I do. We're also going to spend some time here waiting for the .NET SDK to build. That's okay. It's fine. There we go.
I mean, you do realize that these are fictional, right?
Yeah.
I mean, I didn't just have 3 grades.
Sure. We can probably augment them. I mean, you were okay with making decimal pointers, so you could point them to, I don't know, Fred's scores or something like that.
Okay.
But what if we could include some other grades in here very easily, right? I could type them out. That would be fine.
If there was a student that had better grades, maybe we could sort of slurp in all their grades if you know about someone.
Yeah, something like that. Now, those grades for this unnamed person actually come in as a read-only span, right? And so what we're doing is we're using this ... here to spread these. Okay, it's called a spread operator, and it spreads these elements from this other collection, which again happens to be of a totally different type, and spread them into this one. Now down here we also use the ... but in a list pattern it's different. It's a slice, and it helps you define a slice of that pattern to match and say, I could have match the first and the second element, and then here's one that gives me all the rest of them, for example, to slice that out.
So it's different, but it's symmetrical again,
it's symmetrical.
right? It's like you have the single elements for the single elements, and then you have the ... for when you have a whole collection that you're merging into in a collection literal, or that you're extracting out in a list pattern.
Yeah.
So we feel like we got the syntax kind of well balanced there.
So I'm going to go ahead and I'm going to run this again to see if things improved. And boy,
Thank you.
definitely the build improved.
Thanks for letting me borrow your homework.
Yeah. So that's an improvement, and we were able to get all those grades in there. That's fantastic.
Yeah. I want to see if there are questions. Let's see. They're not really related to the topic at hand.
Definitely not. Okay. Definitely not. But I would.
Here's one.
Here's one. Great.
Does this new collection initializer syntax still work for collection interface types? Ooh, this is a great question.
It is a great question. It was kind of what we're going to show
For instance,
next.
I read only list. If so, what type does it resolve to?
What a great question. Almost a softball.
Almost like a leading question.
Yeah.
Because here's the thing, we're not sure yet what happens if, what's going to happen.
It's like a Higgs boson thing. We just don't know what's going to happen.
We build it, but we don't know what it does.
Yeah.
No, we're still deciding the details of this. But there's sort of a related question. What happens if you have a collection literal that is not target type, that is not being sent to something that already specifies the type?
Yeah. As we would say,
like
as we would say in the language design meeting, does this have a natural type? Meaning,
Yeah.
does this, is it just nothing and we decide with the type and the context, or does it have a type of its own and so it can work with var and be type inferred and decide what it's going to be when it goes to iRead-only list, as the question asked?
Yeah, because that probably would, if you instead of var there, it said iRead-only list of grade, the answer would probably be the same. We would use the natural type and it would match that thing. So we're not sure yet. We're still debating this actively. So if you have thoughts on it, that's one of the things we'd love to hear from you, either through Pubble or come and see us in the expert thing if you're here in person, or send us email.
Yeah.
We're trying to still figure this out.
Yeah, and I would say that we are committed to a solution. We believe this should work. If we can make this work, we believe it should work. Steve Tobe is on, he's on duty to do the most efficient thing possible. Cyrus is staying up nights thinking about it.
Yeah.
There's a lot going on here. There's a lot of effort going in. So that's one of the features, though, that isn't in collection literals, that is in a branch today. It's actually in no previews, but I was able to build this out of Roslyn and it was fine. But that's what's there today. This feature is not here because if you check the notes, we're still not sure. Now, there's another feature too about collection literals, right?
Yeah, sure. Yeah.
And we wanted to say that we don't know exactly yet.
Yes.
And that's, we've been looking at things that are very list-like and array-like, but what about dictionaries? Right, that'd be nice. Have little key value pairs. Maybe instead of, just his grades, we could have like
the courses, maybe?
Yeah.
Course names?
Yeah, and so this is your best class. It's probably compilers.
Yeah, that one I did pretty good in.
Yeah, and this would be like, I don't know. Like
not enough to get me on
biology.
the dev team, but
No, definitely not. So, but the syntax that we've been talking about is this idea of having a colon right there to separate keys and values. And again, there's a question. You're not going to want to type out dictionary of whatever. You're going to want to have a var there. So what's the natural type? Yeah. But this is stuff that we are still in active debate on this feature. You can see how much is there, and it's exciting. But yeah, we're going to continue to evolve this and make it better.
Yeah, I want to mention a couple of things about that, actually. First off, it's now common. There's a new C# every year, and you probably observed this. We joked about it even with patterns. It's more and more common for us to add a feature in stages. Like we do something that we know, or we feel we know, is high value in and of itself, and doesn't block the futures we can imagine for the feature. And then as we see how people use it, we chase down those possible extra things you can do, and we can do add-ons. Like if you think about Lambda expressions, they didn't have natural types for 15 years, and then all of a sudden they did. Because pattern matching, we came out with new patterns most releases as we figured them out, and as we saw that there were lots of common usage patterns here. And it could be the same with dictionary literals. They may not make the same release as the collection literals. They may or they may not. But it's fine if they don't. Then they'll be here next year or the year after. So we kind of take this piecemeal approach to design more.
Yeah.
Okay,
sorry,
go ahead.
Go ahead. No, you first, sir.
Oh, thank you. Since I'm up here, but so are you. This is hard. Anyway, I also want to say, you said something great about performance.
Oh,
You said a lot of great things.
Aww.
You generally do. But the thing about Stephen Tobe doubling down on performance, with the collection literals, we're kind of trying to adopt a similar mindset as to what we did with pattern matching, which is it's a fairly high-level feature. It's fairly abstract in a way, works in many different scenarios with different types and so on. But with pattern matching, we were very careful to make it as efficient as we possibly could so that you would not, the reason for not using pattern matching should not be that it's not efficient enough.
In fact, there are cases in pattern matching where you use the pattern matching variant, and there really isn't a way to make it more efficient otherwise in C#.
Yeah. Sometimes it's actually faster than something you would reasonably write because it will do, it will contort itself to avoid computing something twice and so on. So, and we're trying to adopt a similar stance with the collection literals that when they have a target type, they will be the most efficient way we can come up with to instantiate that target type. We're coming up with patterns of APIs that things like immutable array can expose so that we can create them as efficiently as possible. You should not do it manually just because of efficiency. And there's a little bit of a nit with that when it comes to the natural type. Because with the natural, if you just say var something, we don't know what your scenario is. We don't know, are you going to be adding and removing a lot of elements? Are you going to be just, iterating over it once and then be gone? And the answer to what is most efficient is different in those different cases. So probably, I think we will do the natural type. But you can see there's kind of a little bit of a loss of performance guarantee that we can give you there, all else equal. But we're thinking about it. We're thinking about even, can we look at the whole program and see, what, like a whole method body and see what you do with it and do the optimal things there. It's really, it's really important to us that this is not something that you move away from for performance reasons.
Somebody had asked in there, are these features getting surfaced by Visual Studio? It says the text is graying out. I think we're referring to the pair here. The reason that's graying out, yes, it's absolutely surfaced. I just want to point out that it's being grayed out because I'm not using it anywhere. As soon as I used it somewhere, sure enough. Yeah. Just a quick question somebody had there.
Yeah.
All right.
Okay.
Is that all we have?
Let's talk a little bit about field access.
Oh, yeah.
So this is a feature that does not yet work even in Dustin's piping hot bits, as I think we usually say.
Yeah, they're magma hot.
Yeah, but we'll just show it anyway. So auto properties, we have one there, name is an auto property, right? It generates a field behind the scenes, stores the things for you, it auto implements the getter and setter. And we actually were very, very hesitant to add that feature back in C#3 when I had just arrived, because it's a bit of a cliff, right? If everything lines up and you want exactly the behavior it has, that's great. But if you want just one little thing different from the standard implementation, then you have to go totally manual. Then you have to declare your own backing field, declare both your accessors, and so on. And it's kind of like you fall over a cliff, you fall pretty far.
Yep.
And we think we have figured out how to avoid that.
But not without squiggles in the IDE.
Yeah, they'll have squiggles now.
It's not there yet.
It's just because the feature doesn't actually exist on his machine.
I'm just fair
warning. We're just going to do it anyway.
Yeah, we're just going to type what it would be. And so you would type something like in the setter, well, what if I wanted to assign the backing field of this auto property, right? And I could do it like that with this new uncolored, red squiggled field keyword, which will not look like that. It will be, in fact, blue. But, and then I could say, assign to the value, and I could do something a little bit extra with it. Maybe I could call trim.
Yeah, that's the thing that would have cost us to follow. Oh, I just want to trim the input. Oh, you're on your own. Right?
Yeah.
But if we let you actually write accessor implementations on auto properties, and in there you can just use the field special variable, kind of like value is a special variable or special parameter, to read or write the underlying field, even though it's not really a field called field, right? But that's just the variable name that you can use in the accessor. That way you can keep all the rest. You can even keep the getter implementation if you want, being auto-generated for you.
You said, field, it's the thing we can use. Can we really use that? I mean, I might have this is a student, I might have a researcher class who has a field, and we could have a field named field that represents his field of study or something like that, right?
So you're coming to the reason why we do not yet have this feature. It is that if we do it sort of the natural way, like all of a sudden, there's something in all property accessors called field. Well, what about code that already references something else called field in their property accessors, right? Now that all that code is going to be broken. That'll be a breaking change in the language if we do that. We don't really like doing those. So if we do this feature, if we want to do it without a breaking change, then it has to have some weird kind of rule. That is, field in there means the backing field unless you had something in scope somewhere out there called field, in which case it means that one.
Yeah, we do this all the time. We've done this with var, where it's like, well, what if you have anything called var? It's a typical variable name sometimes. Or name of was another one we had to be careful
with. Underscore. Sometimes a discard and sometimes a variable name. So we're having this existential debate right now. Is there a way that we can make C# a little more flexible around having small breaking changes like this? Do the feature the right way instead of the way that's going to confuse thousands of users, just to preserve a few, not pathological at all, but few in number pieces of code. Can we mitigate the break in a way that lets us do feature designs the right way, the simple, easily to explain way, And that's an ongoing debate right now. We're just going to tell you, we don't have answers for you here on stage today. We're just going to tell you this is an ongoing discussion right now. And the outcome of that discussion might determine how we implement this field feature, which relies on that.
It's interesting. Somebody asked actually in the chat, why not just use like value equals value.trim? And it's a similar reason, because that already has meaning in the language, right? To now make that assigned to a field instead of value, because maybe the next line was to do something with value. I just used it as a scratch variable and just adjusted it, right? So yeah, we can't do those sorts of things. We have to be very careful.
And it's not that we can't design this feature without a breaking change. It's just, it's not going to be as nice. So every C# user is going to be punished a little because of our adherence to breaking changes. Some people are going to be punished if we don't adhere to avoiding breaking changes. Can we give a good experience to those people instead of everyone kind of getting slightly inferior?
I got the sense that you just said that everybody's getting punished. That's what we're in the job of punishing people. Is that what you? That's why I took away. Okay, just
no, everyone gets something.
Right.
They just don't get as
sure
much
it won't be
as
in the
they
news
should
tomorrow.
get.
It's fine.
As they should get.
All right. So enough about breaking changes.
Yes.
Let's actually get back to yours. Go ahead and you need to type in your PIN.
Apparently, I told it not to lock, but
All right.
okay.
And
Okay. Yeah.
here we go, because it's
And switch me over.
all right. There we go.
And so it's story time. And let's get a little laser pointer here so we can have sparks coming out of the fire here, like an animation.
That's adorable.
Yeah. So we're done showing you things that are kind of almost shipping. We just want to touch on extensions. Okay. Extension methods happened in
C#3.
C#3.
2008.
They're amazing. Extension methods have been an out-of-the-park hit because they allow your code to be layered differently. They allow software composition differently. Like you can have, because you have a class that's kind of defined in its own domain, and then you can have other domains where you augment that class to interact with that domain, right? Without changing the original class. That's amazing, right? However, we've been stuck in a dead end with it for over a decade where you can only do that. The only thing you can sort of fake that you can put on the original class is instance methods, extension methods. We've had several runs at trying to expand that to other kinds of members, and they all kind of ran out of steam. So we're taking yet another run at that. But to get there, we need to take a little journey. That starts as something else, and then it'll eventually get there. And we have about 6 minutes to do that.
Yeah. No
So you got
pro.
the warm and fuzzy, you're in front of the fireplace, you're ready to go on a little journey.
Cocoa and their
Now you're going to get this white in your face. Oh no, code. Okay, so let's start in almost coming back to alias almost. Like here we have a display method that takes some JSON, but it's a string. But we could declare what we will call an explicit extension. Let's sort of think of it as, for now, as sort of like an alias. But it's like a real type declaration that can be exported and have accessibility and that kind of stuff. But what it says is the extension is called JSON string, and it's an extension for string. Okay? And now I can use JSON string down here instead, and that signals, okay, I'm actually expecting a string that's some JSON. But I'm not limited to just having an alias for it. I can add extra functionality. When I view a string as a JSON string, I can add more function members, like a parse method that parses it as JSON and returns some like weakly typed data object. Okay? So now the method that takes a JSON string can call that method and use that as if it was an instance method. But the one who's calling it can still just pass it an ordinary string.
So is this like you're augmenting it, or you're coercing this type? What's this like? I mean,
yeah, it's kind of like a transparent wrapper.
Like a wrapper. Okay, I could do this with like a ref struct today, but it would be like lots of Einstein-level code, right? That most people don't.
Yeah,
write.
you could do some of this with tricks. And so the idea here is this is like something you choose to do for a specific string. This doesn't make all strings have a parse method. Just the ones that you choose to look at as you take that pair of glasses on, and now they're JSON strings and have a parse method. And you can have others. You can other extensions that do different things. Like an XML string has its own parse method, has the same signature, but it does something different. It parses it as XML.
Yeah.
Okay. You can imagine sort of like TypeScript-like scenarios almost now, where if I have these, let's say I have some wire data, I'm calling them data objects here, like something dictionary-like data, I can put strongly typed views on it. They're the same objects, but I'm choosing to look at this one as a customer and that one as an order. Okay? So it gives me IntelliSense and kind of guides me through working with weakly typed data by putting these overlays on. Just thinly wrapping, transparently wrapping.
Okay. And so these would be extremely low cost, right? Like
Yeah, that's the idea.
the transparent is truly transparent.
Yeah. So now we have a thing that can make an object have extra things, can extend it with extra things. What if we then had implicit extensions? The others were called explicit extensions. An implicit extension then is one that automatically applies to its underlying type here. So this one is indeed extension methods on steroids, right? It is the thing that says, well, actually, all data, when I have this declaration, all data objects will have these extra members. Well, that's extension methods right there, right? Except I also have other kinds of members I can put here. We saw properties before, here's a static method, and so on. And so you can have extension, everything, really.
I mean, what makes this different from making a class that does this kind of stuff?
Because you don't have to new up a new thing that wraps the old thing.
Is there any limit to that?
No state.
No state, I see.
So you can go in and out of that. You don't need to provide extra state, right? It's the same object underneath. You're just putting different glasses on that augment it with new functionality.
Right, so they like extension methods. You're augmenting something new. And the power of extension methods, in my mind, the real power, because like I said, I'm a tooling architect, is that I can dot into it and see what's available. I get IntelliSense, right? And that's what this does for us, right? It gives us the ability to say, okay, I'm going to dot into a data object, and I'm going to get a from JSON method that returns a data object.
The discoverability of it, like just the way that you can find all the link methods. I mean, maybe there are too many and you're kind of annoyed about it, but the way you can find all the query methods on collections today, because the extension methods give you that discoverability. So you get that with all the members here. And that means, so if you use it, this may be obvious, I can now just, if I have this in scope, then I can call to JSON on these data objects that don't have that member inherently. I can call the static method from JSON on the class data object and so on. But maybe we could even implement interfaces on behalf of the underlying type. So maybe I can say that now that I'm giving it these JSON powers, I'm also actually letting it implement the iParsable interface that we just added in C#11.
C#11, yeah.
It's an interface for static members, so it is using all the new stuff. And then we just, you provide an explicit or implicit implementation of that interface member there. And now, when this declaration is in scope, it's as if data object itself implemented this interface, even though the data object declaration had no idea that that interface even existed.
Right.
Okay?
And what's especially cool about this is this also leverages another .NET 7 feature, which is static abstracts in interfaces, where you can now implement static members on existing types.
Just to make the example extra fancy. So this is the kind of thinking that the path we're going down on here with extensions. And it's difficult. We don't know exactly how to implement it yet, and we might have to do things in the runtime.
Oh, yeah.
And
yes. So many things.
This might come to nothing, but it feels like we have the kind of expressive power that, that can really help you do the separation of concerns, the layering of software, and so on, that will, give you the next breakthrough with software composition, pretty much.
It's awesome.
So
cool.
Enough of that. Let's get back to our house slides, our main slide deck. See, it's so cool. I just say that and it happens. Again, questions. Hopefully you're getting questions answered in Pupple. We'll be over in the expert zone soon. Emails. Also, just want to quickly say that this this collection here, if you get this QR code, has most of what we showed and a bunch more learning materials for C# and new things in C#. And with that, I think we're ready to say Microsoft Build. Thank you so much.
Yeah. Thank you.